Ready to level up your DevOps skills? Welcome to K4 Coding Academy. Master Kubernetes, Terraform, and AI. Get real-world platform engineering projects. Subscribe now and start mastering your future.
Welcome to our Terraform series on modules and best practices. Learn how to write reusable, scalable, and maintainable code. Master infrastructure as code with K4 Coding Academy.
Welcome to this explainer on Terraform modules best practices. Look, in an era where AI can spit out code at absolute lightning speed, lacking strict infrastructure as code discipline, that's just a fast track to cloud catastrophe. So today, we're diving straight into how to structure, test, and distribute your infrastructure code so it's secure, reliable, and actually scalable. We've all got these incredible AI coding assistants now, right? But here's the reality check. While they definitely help us write infrastructure much faster, throwing unmanaged, monolithic AI-generated code into your cloud environments is a recipe for massive drift and terrifying blast radiuses. Sure, AI can write the lines of code for you, but it absolutely cannot design your organizational discipline. If your Terraform setup is basically just a collection of copy-pasted snippets, you're building a house of cards. And that brings us to a quote from our source material that really hits the nail on the head. Making Terraform code changes without automated tests is a gamble. That's our starting point for today. We're going to take you from writing throwaway, cross-your-fingers configurations to engineering production-grade, rigorously tested Terraform modules. Here is our roadmap for this explainer. We'll start with architecture and repository structure, move into writing clean configuration, hit automated testing and linting, cover documentation and versioning, and then wrap up with a summary and next steps. All right, Section 1. Architecture and repository structure. Let's look at how we physically organize our code base to prevent total chaos. So, a properly scoped module shouldn't be some giant monolith that builds your entire VPC and databases in one go, nor should it be a useless micromodule that literally just creates a single tag. It really comes down to three core principles. First, encapsulation. Group things that always deploy together. Second, privileges. Keep your high-privileged network resources totally isolated. And third, volatility. You've got to keep your slow-changing, long-lived databases far, far away from your constantly churning application servers. Once you've scoped everything out, where does it all actually live? This brings us to the great organizational debate. A single, easy-to-navigate monorepo versus highly isolated, independently versioned multi-repos. A monorepo makes cross-referencing super easy, but honestly, it can get pretty cluttered. On the flip side, a multi-repo heavily isolates access, which is fantastic for strict security, but it does demand a lot more overhead. Whichever path you choose, maintaining a consistent structure is what's absolutely crucial. Moving on to Section 2, writing clean configuration. You've got your repository structure locked in. Now let's dive into writing the actual code so it's clean and maintainable. Look, every successful module relies on a predictable file structure, so anyone on your team can open it and instantly understand what's going on. Main.tf is for your core resources, variables.tf is for your inputs, and please, for the love of all things cloud, always use clear types and sensible defaults. Outputs.tf should maximize outputs for downstream modules. And finally, versions.tf is where you lock in your minimal Terraform and provider versions to avoid those nasty, unexpected deployment surprises. In practice, securely sourcing a module from Git means using a specific commit reference. See that long string right at the end of the URL? That guarantees you are pulling exactly the code you expect. It completely prevents that nightmare scenario where someone updates a main branch and accidentally brings down your entire production environment. Alternatively, you can source modules directly from an HCP Terraform private registry. What's really fantastic about this approach is that it cleanly handles all the downloads and strictly controls access using API tokens. Your downstream consumers don't even need access to the underlying source code repository. They just pull it directly from the registry, which acts like this pristine, perfectly versioned catalog. Okay, Section 3, automated testing and linting. Let's transition to the phase that truly separates the amateurs from the pros. When we look at the primary testing tools, Terraform's native testing uses declarative HCL and is blazing fast for module contracts and plan-level assertions. On the other hand, TerraTest, which is written in Go, is your heavy-duty option. It actually goes out, deploys your infrastructure to the cloud, runs real end-to-end tests against live endpoints, and then destroys it. The best practice here? Use both. You want native testing for those lightning-fast checks and TerraTest for hardcore, realistic cloud validation. But hang on. Before your tests even execute, you absolutely need static analysis. These powerful security liners act as your automated guardrails to catch policy violations early. Tools like Checkoff, Terrascan, Trivi, and Kix can scan your HCL code in literal milliseconds. They ensure you haven't left an S3 bucket publicly readable or accidentally hard-coded an admin password long before Terraform ever attempts to apply that code.
When you combine all these tools into a GitOps native CI/CD workflow, it's honestly magic. Think about it. You open a pull request. Instantly, your CI runs the linters and the tests. If everything passes, the plan is posted directly into the PR comments so reviewers can see exactly what's going to change. Once it's approved and merged, the infrastructure is automatically applied. Boom. Bad code is completely blocked at the door.
Moving right along to Section 4, Documentation and Versioning. Your code is clean, it's linted, and it's tested. Now we need to ensure other teams can actually figure out how to use it.
Because let's be real, the difference between a module that only its author can use and one that the whole team adopts comes down entirely to documentation. Without docs, your module is basically useless to everyone else. But here's the good news. You don't even have to write them manually anymore. Tools like Terraform docs can automatically parse your configuration and generate beautifully formatted markdown tables based directly on your variables and outputs. Just hook it into a pre-commit routine and your documentation is always 100% up to date.
Next up is versioning. You have to strictly follow semantic versioning here. Removing a variable or changing a resource in a way that forces a replacement, that's a major bump. Adding a cool new optional feature, minor bump. Bug fixes and doc tweaks or patches. Blindly bumping major versions makes your entire module look chaotic and will definitely break downstream consumer deployments. You really have to treat your module like a legitimate software product.
So why is versioning such a big deal? Well, as this setup shows, while module authors should keep constraints a bit flexible in their providers, the consumers of those modules must pin specific versions in their root configurations. By pinning to, say, version 1.1.0, the consumer ensures absolute stability. That way, when the author eventually releases version 2.0.0, the consumer's infrastructure won't just unexpectedly update and break everything.
And that brings us to Section 5, Summary and Next Steps. Let's quickly wrap up our journey through the module lifecycle.
Here are your 4 core pillars of success to take away. 1. Scope your modules strictly by privilege and volatility. 2. Maintain a highly consistent file and repository structure. 3. Enforce rigorous automated testing using both native Terraform test and TerraTest. And 4. Automate your documentation while strictly applying semantic versioning. If you do these 4 things, you are going to master Terraform at an enterprise scale.
I want to leave you with a provocative question. Is your infrastructure truly code, or is it just a liability waiting to happen? Think about that as you review your own modules this week. Are they engineered, rigorously tested products, or just risky scripts waiting to break? If you found this explainer helpful in shifting your perspective, please hit that like button, share it with your team, and subscribe for more deep dives into engineering best practices. See you in the next one.